Alright, gang. Section 1.4 is about solving equations. We're still reviewing things from your deep, dark past. And well, let's dive right in. Solving equations. This is about as easy or as simple as it gets, I would imagine, having to solve an equation just like this. X plus 3 equals 5, and we're supposed to be solving for x. You know, what does x equal, right? And if you recall, this is usually going to be about working the equation and altering the equation using legal moves, of course, but ultimately getting x all by itself. Which sort of brings me to this, kind of just a quick little question. What does it mean to be a solution? You know, when someone tells you to solve something, like that's a very specific directive. You know, those, like when the directions tell you to solve, you know, they're talking about something very specific, a very specific sort of situation. And if you're asked to find a solution, what does it even mean to be a solution? Think about it for a second. What does it mean for something to be a solution? And this is one way to put it. A solution is any number that could replace the variable to make the equation true. So as we work the equation and alter the equation, you know, to get x by itself, what we're really trying to figure out is what could we replace the variable with that would make, say, this one, x plus 3 actually equal to 5? Like, what number plus 3 would actually equal 5? And of course, you know, the solution to this equation is 2. You know, there's one answer and one answer only, one solution only. And that one solution is 2. X would be 2. 2 plus 3 equals 5. And just a quick little side note, you know, just to cover all my bases and get you thinking in like full context and looking at the full perspective, the full big picture. Just try to remember, it's not so important right now, but that one variable equations aren't the only thing in math that can have solutions. You know, we can solve other things or talk about the solution or solutions, foreshadowing, to other things other than one variable equations. Anyway, the step-by-step process of solving equations should end with the variable only appearing once and alone on one side of the equation, which means on one side of the equal sign. This process involves using the following properties of equality to legally move things around and tweak, alter the equation. So you probably, you know, it's such a behind the scenes, just like vocabulary thing. I don't know, like it's such a formality, I don't know, formal thing. Like when you alter an equation, I'm sure you don't think about all the name brand properties, you know, all the properties that you're utilizing by name. You know, like when you add the same thing to both sides. Well, actually, let me change it up. What would you do to both sides here to get x by itself? You would subtract 3 from both sides if you were going through those motions of just getting x all by itself. So you probably don't even realize or never think about how there's a property that says you are actually allowed to subtract the same thing from both sides of an equation. It's the subtraction property. It's the subtraction property of equality, okay? Which says that you're allowed to subtract c from both sides of things that are already equal, that are already balanced, you know. If two things are equal, you could subtract the same quantity from each side and it would still be equal. Anyway, to move on from this, the Keystone exam, which we have to worry about in the days of 2019, which is where I'm at right now. When I'm at right now? Whatever. But in the days of the Keystone right now, they could potentially ask you to identify by name, say, a subtraction property of equality. For example, if they showed you some, you don't have to write this down, but if they actually showed you a couple of steps like this, and they said, what property did you just use? Like namely here, right here, what property was that? You would have to kind of identify that by name, the subtraction property of equality. I mean, but you know what? From what I've seen released as sample questions that they give you to study and stuff, it's the most likely property is, or whatever, is the distributive property. That's what I've seen the most, that you have to kind of identify by name as the distributive property. But hey, I mean, it's all fair game, I believe. For our section of the textbook right now, just a quick reminder about the substitution property. If A equals B, then B may be substituted for A in any other equation or expression or whatever. Okay, so you'll see that in action soon enough. But hey, here's some old school, like this is not a new thing based on what you've done in the past, solving equations. So a quick reminder and review of the strategy here. Normally the first thing you want to take care of first, if it applies, is clearing any bubbles, right? You don't want to really start solving for x, moving things around, doing anything major that starts to get x only on one side and then all by itself. You don't want to start to do any big moves like that when there's parentheses going on in bubbles. So the first move is usually clearing bubbles with the, speaking of the distributive property, speak of the devil. So we're going to use the distributive property first, and we're distributing a -7. So -7 times 2x is negative or minus 14x. -7 times -13 is, oh my gosh, I'm going to do this in my head, 91, positive 91. Yeah, I'm gonna take a gamble and not double check a calculator, even though you probably should when you're not 1,000% positive. But -7 times -13 should be positive 91. And we're also distributing the 3 through the bubble, so 3 times -2x is -6x, and then 3 times positive 9 is positive 27. Now, again, okay, so maybe the next thing you would look to do as like priorities, like I said, the first priority, if it applies, is clear bubbles. The next thing I would look to do, and textbooks probably emphasize this as well and agree with me, if there's any like terms that can be combined together that are already on the same side, like over here we have a 3x and a -14x that are already on the same side as each other. Just combine them. That's the next step. So 3x minus 14x, that's going to be -11x, I believe. Everything else just comes down all lined up, neat and tidy. And now I can move on to well, I see that there's x's on both sides. You need x only on one side. Now here's where you can, here's whatever you do next is almost like a matter of preference. This is one of those not unique situations, but this is a very sort of well talked about situation in math classes, right? Sometimes people base their decision on, well, should I add 6x to both sides and, undo this minus 6x from this side? Or should I add 11x to both sides, undoing the negative 11x from the left side? Again, it kind of depends on whether you're someone that likes to have your x variable always end up on the left side versus people that want positive coefficients on their x variable. So here's the thing. If I was someone that always just wanted to put my x variable or whatever variable, x, m, y, n, whatever. If I was someone that wanted my x variable to be on the left, I would be adding 6x to both sides. But you're going to get a negative 5x, right? Because a negative 11x plus 6x. And some people cringe at that, like, negative 5x, I mean, whatever. Some people cringe at it, and that's fine. So a lot of people might decide to do this. I don't know if I'm one of them, but let's just do it that way right now. Some people decide now to add 11x to both sides, which means your variable is going to be on the right, but at least it'll be a positive 5x, and the 27 comes down, that's gone, and we still have a 91 on the left. See, some people like that number to be positive no matter what, even if that means your variable is going to be on the right, because that doesn't matter. And so now that we've decided that my x variable is going to be on the right, now we want to get this x all by itself on this right side. And so, stupid thing, didn't realize I hit purple. Hello. Very particular about my colors right now. Sorry, I don't think it was the board's fault. 91 minus 27. Actually, it was probably my fault. 91 minus 27. Oh my gosh. 64? 64. We're going to go with 64 because reasons. And so that'll leave 5x. I'm going to grab a calculator, just at least looking ahead of here. I mean, I am almost positive. Yeah, 64. And so that's not there anymore. And so now I'm one step closer to having x, 1x, all by itself. The only thing I got to do now to finish getting x all by itself is divide both sides by 5 to cancel out the 5s. And so 64 fifths. And so some finish up commentary here, because I know there's no reducing. And that is probably going to be arguably like the final answer you want to go with in that version, 64 fifths as a fraction. Not that it's not possible that you couldn't say the answer as a decimal, which is 12.8. I'm okay with that answer, especially because 12.8 was a clean decimal, and by clean decimal I mean we didn't have to round off at all. Like 12.8 is the exact answer. And we like exact answers, these days. And from here on out, if not already, like from here on out, we like exact answers. This is an exact answer, so I'm more than okay with it. This is also an exact answer, which I'm going to say that, let's say you were taking the SATs or the Keystones, I would say there's at least a slightly better chance that the final answer would be in fraction form, reduced fraction form, that is. But hey, I'm sure you're aware that 12.8 and 64 fifths are the same. But moving on to the next type of example here. What is this called? Like literal equations, I think a textbook would describe this as. Basically, given a formula or an equation, a lot of the times it's a formula, like a real life formula in physics or just the real world, right? So taking an equation with multiple variables in it, or just a formula with multiple variables in it. And see, right now, this temperature, this formula involving temperature stuff, is solved for C. It's solved for Celsius. But what if you wanted to solve it for F? Okay? And that's the idea here. Taking an equation or a formula that's solved for one variable and resolve it for a different variable. In other words, C is all by itself on the left side. We want to move the equation around, tweak the equation, work the equation to where F will be all by itself instead. So I'm just going to recopy this, I suppose. You. See what I'm working with here? All right, so what would be the first thing to do to start to get F by itself? I suppose you could distribute the 5/9. That wouldn't be so horrible. I'm not going to do that. But you could. Wouldn't be anything too wrong about it. What I'm going to do is, see how it's like 5/9 times the bubble? We're essentially going to divide both sides by 5/9. Once again, let me say that again. We're going to divide both sides by 5/9 in order to cancel this out and get it out of that side, the right side. But remember, how do we divide by a fraction? How do you divide by 5/9? Isn't that the same as multiplying by its reciprocal, or as I say, refliprical? See what I did there? Play on words. So so multiplying by 9/5 cancels this out. So on the right side, it's just going to be F minus 32, and we don't need the parentheses anymore. Over here, it's going to be, now, you could leave the fraction separate over here and say 9/5 times C. Or you could, let's see, I got to make an executive decision here. Do I want to write this as 9/5 times C, or should I write it as 9C over 5? Like, should I remember that I can think of C as C over 1 and write it as 9C over 5? I don't know. It's pretty much a horse apiece, but I'm just going to go with this. 9/5 C. Even though you could write that as 9C all over 5. Anyway, moving on. I hit green again. It's not letting me select stuff. Sorry for that emotional outburst there. And then the last thing to do, remember, don't lose sight of your goal here. Don't take your eyes off the prize. The overall objective here is to just get F all by itself. So the last thing we do is add 32 to both sides. And so we're just going to get 9/5 C plus 32. I mean, we can't really combine anything. It's just going to be 9/5 C plus 32. And over here equals F. And we can say we're done. If you want to switch sides, like if you want to just say instead F equals 9/5 C plus 32, just so that like the F variable is on the left, you could swap this. You know, it's the symmetric property. Look at me. invoking or calling out what property this is. But yeah, you could bust out the whole symmetric property here and just kind of have the left side and the right side swap if you want the f on the left, whatever. But next example talks about a dog kennel owner that has 100 feet of fencing to enclose. Is this a to enclose a rectangle? Hey, I hope your notes don't have that typo. I wonder if this is a original copy thing or my screenshot making picture. Anyway, whatever. 100 feet of fencing to enclose, I'm going to say, a rectangular dog run. She wants it to be 5 times as long as it is wide. Find the dimensions of the dog run. Okay, this is kind of a classic type deal where they're talking about a rectangle, and when they say that there's 100 total feet of fencing, doesn't that pretty much pertain to the perimeter of a rectangle, this rectangle? And when you're talking about a rectangle and you're talking about perimeter, don't you want to talk about how a perimeter, I got of two minds there. Should it be a capital P or a lowercase p? Sorry, I couldn't make up my mind in the heat of the moment. But so 2 times, and we don't know the length, we don't know the width. We actually know the perimeter is supposed to be 100, but we don't know. That's ugly. We don't know what the length is right now. We don't know the width, but we do know that we want the length to be 5 times whatever the width is. So that's where you kind of write sort of a second equation where we know that if we take 5 and we multiply it to whatever the width is supposed to be, 5 times the width is going to equal the length. And that's where we can now invoke the substitution property. And okay, so if L is basically the same as 5W, I can replace this L variable with 5 times width. So here we go. And because whenever you have an equation that you're supposed to ultimately solve, you can't really do it when there's multiple unknown variables. But if you have an equation with only one variable at a time, you can solve it. So which is what we have right here. Now, with that little substitution trick, now we have an equation with only W in it, which we can proceed to solve now. 10W plus 2W, you should make that 12W. And now we're going to be dividing both sides by 12. It's going to be a not so perfect answer here. 8.33, that's what I was afraid of. 8.333333 forever. Well, you know what that means. I'm going to say that W is 100 over 12, which means 50 over 6. 50 over 6, which means 25 thirds. Wow. What is this, feet? So I know it's kind of a weird answer here, but the width is going to be 25 thirds feet, which is, again, basically 8 and 1/3, like 8 and 1/3 feet. Ew, I know. But Do they want both dimensions? Because look, remember, this is the width. If we were only supposed to find the width, we'd be done. But again, don't lose sight of the prize here. Don't forget what the directions we're ultimately asking for. Find the dimensions. So both. So if the width is 25/3, isn't the length supposed to be 5 times that? So 5 times that is going to be like 125 thirds feet. Okay, just hopefully I don't have to re-explain how to do 5 times 25 thirds. You know, a lot of people think of it as 5/1. That helps them a lot, just to be ultimate, super comfortable. 5/1. So we're really only multiplying 5 to the numerator to get 125 thirds feet, which is, like 41 2/3 feet, whatever. But yeah, usually you want to go with exact answers. I'm not saying it's not possible. You're taking the SATs or you're taking the Keystones or something. I'm not saying that you wouldn't see in the choices 8.3 feet or 41.67 feet. That's possible, I suppose, but it's just I don't know. Usually answers are given in exact if possible. Final example for the notes here. The lengths of the sides of a triangle are in a ratio 3 to 4 to 5. So the ratio of the lengths are 3 to 4 to 5. The perimeter of the triangle is 18 inches. Find the lengths of the sides. Okay. Long story short, when they say it's 3 to 4 to 5, that doesn't mean that the sides are 3 inches, 4 inches, and 5 inches. I mean, it could, but 3 to 4 to 5 just means like it's in that ratio. You know what I mean? So it does mean that the one side is 3 times something, and the other, one of the other sides is 4 times the same something, and then that largest side is 5 times the same something. You know what I mean? Like this could be 2. Like if you had, let's say that something was a 2, you could have a triangle that have sides of 6, 8, and 10, and they would be in this ratio. That reduced overall ratio. Anyway, so the bottom line is it's 3x, 4x, and 5x, you can say are the 3 sides. And apparently if you add all these together, you get 18 inches, because again, this is about perimeter. Perimeter is about adding up all the sides to get the perimeter. And so this becomes a very simple equation, doesn't it? 7x, 12x equals 18, and then when we divide both sides by 12 to solve for x, 9/6. That's not going to cut it. 3/2. I just want to be sure here. 3/2, which that's a fraction answer, which could totally be the final answer you would see in places. But that's 1.5, because that's a clean decimal. But even as I say this, as we talk about what should this look like, is this even the final answer? Find the lengths of the 3 sides. 1.5, guys and girls, it's not even, 1.5 is not even one of the sides. 1.5 is that something that we were multiplying to the 3, 4, and 5. So essentially now we have to do 3 times 1.5, 4 times 1.5, and 5 times 1.5. Just drop my calculator, it's okay. To get our 3 sides. So 3 times 1.5. It's the best way to... how much do I want to write out here, man? So 3 times 1.5 is 4.5, so 4.5 inches? Inches. 4.5 inches. I'm not going to write it. 4 times 1.5, that should be 6 inches, right? Let me check my calculator. Yeah, 6 inches. And then 5 times 1.5, ooh, that should be 7.5, but again, 7.5. All right, 4.5 inches, or 4.5 inches, 6 inches, 7.5 inches. And that does it. Now, I was looking at the homework assignment, and there's also one of those ones where like you have 2 airplanes flying away from each other, or 2 buses playing catch-up with each other or something. Make sure if, like let's say you're absent at home and I forget to, or not forget, but if you're absent, you may or may not be in class when we talk about those homework problems, and just maybe do 1 or 2 of those homework problems in class together. So make sure that if you need, you ask somebody, or ask me, would be the best case scenario, how to do those homework problems, or any homework problems that you find are still a little bit, vexing, even after looking through these notes in this video, okay? But that's section 1.4.